Welcome, everyone. If you're just joining us, a quick reminder that you can submit questions using the Questions tab at the top of your screen. We'll take as many questions as we can at the end of the presentation. And if we don't get to your question, don't hesitate to send it to webinar@neo4j.com, and we'll be sure to have someone follow up with you. Be sure to tweet about today's event using hashtag Neo4j, and you'll be entered to win some really cool Neo4j swag. And now here's Lance Walter, Chief Marketing Officer at Neo4j, to introduce our next session, Developing a Knowledge Graph of Your Competency, Skills, and Knowledge at NASA.
Our next speaker is David Meza. David is a senior data scientist at NASA, the US's National Aeronautics and Space Administration. David's been with NASA for more than 2 decades. He's held a wide variety of roles, things like knowledge architect. He's been a program manager as well as a technical lead. David has a master's degree in engineering management and a doctorate in education from the University of Houston, Clear Lake. You know, as a bit of a space nerd myself, I love some of our connection sessions where we talk about where graphs intersect with construction of spacecraft, with space travel, with space programs. I couldn't be more excited for the session. I imagine you are as well. So let's get into it. Welcome, David.
Thank you, Lance, for that introduction. It's a pleasure to be here and trying to go over some of the things we do at NASA with graph databases and knowledge graphs. So again, everybody, I'm glad to be here. I want to talk a little bit today about how at NASA we create knowledge graphs when we start looking at our different data sets. About 8 months ago, I came across an opportunity to move up to headquarters from Johnson Space Center to really take a look at our human capital domain and how we can encourage our people analytics groups to utilize improved data science methodologies as well as graph database to take a look at our people issues that we're having. So today I want to talk a little bit about one particular area where I'm working on workforce skills and what that means to us at NASA. And primarily because we had a long-standing question. We're trying to get back to the moon and on to Mars. What new skills do we need? What skills do we currently have? And how are we going to reach those gaps in the skills that we're missing for now? So knowledge graphs became a very good way of looking at things and trying to identify that. So what I want to show you today is how I built that type of a knowledge graph and how you might be able to take a look at that problem for yourself. So when you build a knowledge graph, some of the first things we try to do is first understand the domain. You really have to have a good understanding of the natures of the things that are going across your organization within that domain, how you're utilizing your workforce, where the different skill sets may be accumulating, and what the progression of those careers and those skill sets may be. Once you understand your domain, you need to ask the questions. What are the questions you're really trying to define in there within that domain that you need answers to? Once you understand the questions you have, then you can start looking at your model, understanding what kind of data sources you're going to need to integrate into your model, and start looking where to find that data, whether it's internal or external to your organization. And then once you get all that done, you can finally start having some fun and doing some of the analysis, especially using some of the latest graph data science algorithms that have been made available within Neo4j, and really play with that data to come across with some good and interesting indications of how you might be able to work through your workforce skills information. So let's start off first with understanding your domain. As I previously stated, we were really looking at how to go back to the moon and onto Mars and the skill sets we're going to need. And this is something I believe that is really growing across industry, especially in the times that we're currently having with the COVID situation. Many organizations are looking at, they need to reskill their employees because of their different work capabilities they need, their different work environments. In this particular research from Gartner, it looks at several different organizations and industries and what they're looking for different skill sets. Car manufacturers have to quit building cars and take a look at building ventilators. While some of the skills are similar for that, what other skills are necessary to do some of that? Workforce needs to learn how to work virtually, and what skill sets do we need for that? So there's a lot of things we need to look at and a lot of questions about how we're going to get these types of skills into our organization and identify those that already have these skills and how can we upskill those that need further training. So Additionally, as we were taking a look at this environment and different skill sets in another survey by Gartner, it shows that the emergence of new tasks and responsibilities for employees were something that was expected or most significant within an organization by human research officers. They were seeing that these types of new skills and new responsibilities that were changing across an organization, and we needed to identify good ways of not only understanding what skills are necessary for a work role or an occupation, but again, identifying what skills are within an employee, but how those skills are clustered across a program, a project, or even a center or a location. Those are things we were trying to look at because of these changes in how we're handling our skills across industries. And additionally, it was because of this survey, again, you said building critical skills and competencies are the most important thing that human resource executives are finding. So starting to develop and trying to understand our domain, we looked at the top level of industries and what they're looking at skills and worked our way down to what's the most important thing that human resource executives are looking for in their employees. And again, the top thing here is building critical skills and competencies. So after you start looking at your domain, you start thinking about the questions. What can you do with the information you have? What should you be looking for? What's keeping your organization awake at night? Building knowledge graphs is fun. It's exciting to see how they build, and it works a little bit at least in my opinion, you can do it a lot easier within a graph database than you can within a relational database. In a relational database, you consistently have to understand your schema before you develop the database. At least in a graph database, you can continuously add more information as you grab it. And it helps you to, as you get more questions, you can then go find more information and more data that you can apply to that knowledge graph. So what are some of the questions we were looking at? Initially, what is my workforce skill map? Where are they? Where can I find these types of skills across my organization? Again, within programs, projects, or people. How are they grouped across locations? And can I identify adjacent skills? If I know somebody has Cypher, maybe they also know SQL. Or vice versa. Some people that know Python may also learn R or Fortran or some other type of programming platform. What are the things that we're finding within our organizations? So if I need somebody with a particular skill set, but we don't have that, can we look at other people, these same people with a adjacent skill, that we can upskill them and use them to try to create the skills that were necessary for us? And other common questions were, I want to change my careers. I'm tired of being a management analyst in programming or project manager. I want to get into IT. What should I learn? What can I do that? I'll show you a couple of things in how we looked at that utilizing graph data science algorithms to come across some of those answers. So once you've looked at your domain, you've asked the questions, now you got to start thinking about your model. How are you going to look at this? So in my case, I started looking at it from a competency perspective, looking at the different competencies within, in this case, information technology, but you can look at across any type of industry and what we're looking at. So as you can see, there's many layers in that. From the competency level, you got personal effectiveness, academic, workplace, industry-wide, industry sector, management, and occupational specific. All of those are things that we need to look at when we're trying to develop a competency model. So those all become your nodes. And the information within those different competencies become either additional nodes or attributes or properties to those nodes, and they're all related in some shape across that model. It's identifying how those things are related and the values you want to find or store in them to be able to use later on. That becomes the definition of your model when you start building it. So as you start digging a little bit deeper, you start pulling out the different characteristics within that model, or the different things you need, or different elements within that model that you want to try to make sure are incorporated into your knowledge graph. Things such as employee characteristics, their skills and competencies. How do we validate that data? The unique capabilities and requirements for an occupation. What are the organizational characteristics and keywords and identifiers for those occupations? All those types of things have to be thought of as you're developing your knowledge graph in order to make sure you capture the right information to continuously add on to it. And don't worry if you forget something. If you later find out that you want to add another additional node or something else into your graph model, it's very easy within this type of environment to add additional nodes that just expand upon your graph, on your knowledge graph, because that's really what you're trying to do. You're consistently trying to add more and more information into your knowledge graph that helps build those connections and those relationships, so you start seeing the patterns across disparate systems and different types of environment that you may be looking at. So what did we do? We first had to start a look at gathering different types of data sources. Fortunately, there are several governmental organizations, not only here in the United States, but in Europe, in different areas where you can look at, they have databases that have been around for quite a long time discussing occupations and the various elements that make up that occupation. And when I talk about elements, I'm looking at their knowledge, their skills, the abilities, the task, the worker requirements, the education necessary, the training, the tools and things that are required with that occupation. All of that is stored within, in these cases, a lot of relational databases. ONET by the Department of Labor has a great database that you can look at this, which I use as my base for creating the knowledge graph of occupations. I then merged that with some information from OPM for traditional government information of occupations. Many of our classifications are based on OPM guidelines. And then I also looked at the European Skills, Competencies, and Occupations database to kind of do a cross-check on how they may be looking at these different occupations and kind of fill the gaps where we may be missing some occupations within ONET, and make sure we identify the skills not only here in the United States, but across the Europe and across the world. So this kind of gave me the big base that I could utilize to start developing my knowledge base and start off just the occupation side of that. And if we break down even the ONET a little bit more, you can start seeing many different things inside of that builds your taxonomy. Your taxonomies will develop your groups and your knowledge graph and your nodes and your relationships across for your knowledge graph. You have such things as major and minor groups to break up your occupations, different titles, different alternate titles. So you want to start looking across different industries and how they may have a different title for an occupation. You can then start searching through these things. So it provides a wealth of information to add a little bit more richness to your knowledge graph, and allows you to be able to find more information a lot faster by adding all this information into your knowledge graph. So once you have all of that together, you can start playing around a little bit and start developing a model. And in this particular page here, slide here, I'm just kind of showing you a very high level model, how I started breaking down the occupations out of ONET and out of ESCO, because they had very similar characteristics inside of these occupations. And many times you started off with a group over here on your left-hand side of an occupation, whether it be IT or whether it be human resource or something like that, to where you're looking at that major group. And within that group, you have an occupation, a high-level occupation, and then it may be a more detailed occupation or a work role, which breaks down that occupation. Yes, I may be an electrical engineer, I may be a data scientist, I may be a manager, but as you get down into detail, it could be a project manager versus a warehouse manager or things like that. So the work roles change, and because the work roles change, the characteristics of that work role will change a little bit. And then from there, you break it down into the different nodes attached to those occupations, from a task to an ability to a work activity, a skill, and of course knowledge necessary to meet that occupation. All of that starts building your knowledge graph. You start building your relationships, and you're able to develop all of this into a nice graph database that can showcase your information. And for those that are interested, I will be posting the script to build the graph model from the ONET, the open data and ONET information later on my GitHub sites, which I will show you. I'll give you a link to that at the end of the presentation. But you can at least start playing around and looking how different occupations have different skills and skills and knowledge that's necessary for those occupations. So as you take a basic look at the ontology of that graph, just to see how this will work, at the bottom, the base level, you have the instance of the ONET data, which gives you your major group and maybe an occupation. And as you go off that layer, you get down to a little bit finer detail, where you to looking at one specific occupation or work role, and then you go up even further for a custom ontology you start developing within your knowledge graph. So you have ways of layering your knowledge graph to provide different information and pull that information out as projections within your graph database. So let's bring this all together as far as the model itself and what's actually working and how I added more things to it once I've got the occupation database in there. So we look at the left-hand side, we have the occupations, all the various occupations from ONET, ESCO, and any other source I could find, and easily broken them down into different elements. And here I'm just showing some high-level elements of knowledge, skills, abilities, and tasks that get separated, and they become their own nodes with their own attributes and properties. So a knowledge can be found in a particular occupation. And within ONET, they also assessed all of these elements and gave them a scale or a ranking based on a various scale, some of them being relevance or importance, and gave it a value between 1 and 5, utilizing industry professionals and domain experts to say how important this element may be for that occupation. And I'll show you later on why that's important, and when you start looking at deciphering some of this information through your graph algorithms. But all that information was used, all the text information from these elements was used to develop a vocabulary and train a doc-to-vec model that would sit there as a way of inferring from an employee, because now I've ingested employees. I've added to my knowledge graph by bringing in my employee information and all the information I have on them, such as their job descriptions, their performance evaluations, their resumes or CV, and any of their training history. And I've taken that information I have and used that to infer against the model what knowledge, skills, abilities, or tasks that may be associated to that individual. So now I've enriched my knowledge graph a little bit more. I have an occupation that starts on one side that connects to a knowledge, skills, or abilities, that also connects to employees. So I'm starting to build the process for how I'm going to be able to find what employees have the skills or knowledge that I need for certain occupations. Once I've inferred that information onto the employee, I can then start putting that into the Neo4j graph database that's going to hold all my information and develop that knowledge graph here in the middle. That gives me the base of what I'm starting to search for. Utilizing the Neo4j graph data science library, I can then take that information and start looking at things such as skills gap, career paths for individuals, succession planning, and even strategic alignment. Do we have the right skills in the right locations in our organization? All of that can be done with the information being ingested into the knowledge graph. So let's take a little look at how that may turn out. So I'm going to show a few images here and just kind of go over what it looks like. It'll definitely be easier once you start visualize this into Neo4j web browser or Bloom or any other visualization tool. But for the sake of, just for this presentation, just wanted to kind of outline a few of the various images that you may be able to get. So in this case, I just looked at the elements that are associated to an occupation, and we're able to enrich this occupation with a huge amount of different elements. If you look at the top, we have things such as worker characteristics, worker requirements, experience requirements, occupation requirements, knowledge, education, basic skills, cross-functional skills. All of those are in some way, shape, or form related to an occupation and to an employee. And then we can start building upon that by bringing in more information about the employee. So once you have all that information, you can do certain things such as compare work roles. So one of the things we were asked early on when I joined the Human Capital Group about less than a year ago was we wanted to really increase or enhance our data science capabilities across our organization. But we knew people were doing data science, but we also wanted to train other folks to do data science and may be interested in it. So you can compare really quickly here. It's a data science work role in the center here, and it requires certain knowledge. And by doing this comparison across the other occupations, we find that it comes very closely, it has some very similar knowledge, or at least 50% of the knowledge a data scientist may have. It's also what a software analyst may have. So if I want to enhance or grow my data science community within NASA, maybe I ought to go look at people that are software analysts and see if they're interested in and maybe already have the skills, so I don't have to go out and find brand new data scientists. I can train the people I have currently that understand the NASA environment to get to that level to be the data scientist that we need. So this kind of gives you an idea of how to use this tool to be able to find individuals that may fit into that category that you're looking for. So, and how that is done is by looking at the different elements within these occupations. And what I wanted to show you here is what it looks like when you pull out just the basic skills from an occupation. Now, there's various different elements that are associated to an occupation that I've mentioned: basic skills, cross-functional skills, knowledge, abilities, tasks, so forth. But in this case, and they all look very similar. So if you pull out just information, we've got the occupation or the title of the occupation on the left-hand side. It gives you the group of that element, in this case a basic skill, and the description of that element, what that element what is necessary for within that occupation, as well as the value that I mentioned earlier that's been assessed by professionals and domain experts. So in this particular case, this first basic skill, understanding written sentences and paragraphs in work-related documents, it's got a ranking of 4.5 out of 5. So it's very highly necessary for somebody to be able to do this basic skill if they want to be a computer and information research scientist. So again, it's hard to see it in this one little slide, but it gives you the ability to go through all of these elements that are here with their value and pull out just those values that are important to that occupation, and then see who has those types of those skills or elements that may be necessary for your use. You can also use these values as weights and as other parameters inside various algorithms later on as you start doing more analysis and looking at similarity comparisons. So here's a quick example of how you might be able to do that and use some graph data science algorithms to be able to look across your organization. For an example, let's say I'm a management analyst that's looking for a career change, and I really want to get into the IT field. So in this particular case, I first create a projection or a cipher projection here of a graph looking at the occupations and the knowledge across specific occupations. Here I'm looking for occupations that fall into these particular series. And understanding the domain, I know that a 2210 is an information technology specialist, and these others are various different management analyst types of career occupations within the government. And then I want to match that to where the knowledge is found in those occupations, with looking at the importance scale with a rating of 2.99 or higher on a scale from 1 to 5, and bring that out as a projection within my graph database. Now that I have that projection, I can then call the node similarity algorithm out of the graph data science platform to take a look at how similar an occupation in the 2210 area is to something in the other management analyst occupations. And the resulting sets that are returned from here is we take a look at management analysts. These are various different IT occupations that are very similar to the same skills or knowledge necessary to be a management analyst. And the easiest one to probably look for here is, let's say I'm a project manager and as a management analyst, I could become an information technology project manager. I've got almost 43% of the skills or knowledge that's required for that. A little bit more training, I can go into an information technology project manager. Or if I want to be more of a business intelligence analyst, I'm pretty even closer to that it's just add a little bit more analytical type of skills or knowledge and be able to become a business intelligence analyst. So this gives you an opportunity or a mechanism to identifying those ways of career path, but not only career change, but it could also do career path. If people started off in one career and it's progressively grown, you can do longitudinal studies across this to see how the careers have changed, having that all ingested into your knowledge graph to see what has generally been the next step of a career in somebody's path along the way. And all of this can be envisioned in a knowledge graph. So, talked about occupations, I've talked about adding the people, and then comparing those two together, we add a little bit more information. This is the fun about a knowledge graph, is you can consistently add more information. In this scenario, I've added the information of where an employee charges to, what cost center, what project, what program, what mission, and what theme they may be charging to. That gives me a little bit of opportunity to understand how much of their time is spent in a particular project or a program, which then allows me to, since these individuals, these employees also are related to a skill, I can start identifying what skills are associated to a particular project. Where are skills isolated? Do we have gaps? If I need skills in a certain project, but I don't have them, where can I find them in other programs or projects that I can shift them around? So it gives us an opportunity by adding additional information into my knowledge graph, gives me that opportunity to be able to start asking additional questions and find additional information or answers for management. So to take that down a little further, this is one individual. This individual here who charges to a couple of different cost centers, going to different projects, different programs, onto the mission, into the theme, and then the mission. But they have all these various knowledge capabilities here, or actually in this case, are cross-functional skills that are associated to the occupation that they are currently employed in. So in this scenario, you see this individual has these cross-functional skills, and they're charging to these particular projects. You also see the weightedness of the edge, showing that these are the cross-functional skills that are more important. They're weighted by that value again that I talked about, showing that these are the more important skills. So I can start pulling the weights that aren't important to look at those. So imagine doing that across all of the employees across a program or a project. You can start summing up and identifying where your skills are. You can start seeing where your gaps are. You can start seeing how to shift people around, how to align them. And all of this works very quickly and easily within a knowledge graph, utilizing some of these graph algorithms that are attached to that. So as we progress, there's still more to come. That's a start. That was a start. I've been working on this just for the last 6 months, trying to get some of these information in there, starting to evaluate some of the things we can do. The next things to come are developing things such as a recommendation engine. So as an employee, we're going to start to add information like an employee profile into a talent marketplace where they can self-identify their skills, have them validated and verified. And then if I'm an employee and I have certain skills, I can try to search what jobs are available for me within the organization that match my skills and knowledge. Or maybe I'm a project manager that needs certain skills. Who's available that has this? Or maybe I'm just looking for an expert in a certain field. I can start doing some of that. We can also start looking at developing training plans with this information. This is the training that people have taken to get to these careers and these levels that they're at. Here's some other training that you may want to look at based on your decision on where you want to go into your career path. And then, as mentioned earlier, we can outline the career paths a little bit better as we get more into a longitudinal study on career paths and how that goes. So those are things that we're working on, more to come. Hopefully, that'll allow us to really enhance our employee experience and give them the opportunity to seek out projects and work in areas that's exciting to them, but can also benefit the mission of NASA, again, as we try to get back to the moon and onto Mars and really showcase the talent that we have at NASA. So with that, I hope that you guys had a good opportunity to enjoy my presentation. Here's some information that I have here. If you want to reach out and contact me, feel free. My Twitter handle, and eventually I will post the script to ingest the ONET database into a graph database at my GitHub account. Thank you very much for the time. I appreciate it, and I'll open it up for questions.
Hi there, David. This is Greta. Thank you so much for that. That was such a great presentation. Thank you so much for joining us today. So we have a lot of audience questions coming in, and a reminder to our audience, go ahead and type those into the Q&A portion of your control panel. We'll be taking a couple here now, and then if we don't get to them, if they're Neo4j related, someone from our team will be reaching out. If they're NASA related, we'll be sure to connect with David and get the answer for you as well. So go ahead and type the questions in. If we don't get it today, we'll get to you soon and get the answer to you soon. And you can always reach out to us at webinar@neotechnology.com. But okay, so we have a ton coming in. Lots of questions about the graph algorithms that you were using. Can you kind of run through what those were, probably both within the Graph Data Science library itself and then any external ones that you're using as well?
Definitely. So great question. I mean, I think I'm really excited to see what Neil has done with the Graph Data Science platform over the last couple of years. It was one of the things that I felt was missing in the platform several years ago when I started first working, and I'm glad to see the movement and the growth in that. Alicia Frame has done fantastic, and Amy Holder, they've all done fantastic in working on these things. So some of the things that I've also used, the one that I showed here was the no similarity, utilizing basically Jacquard similarity across the different nodes. But there's various similarity concepts that are coming across from a cosine to Pearson if you just look at a similarity. But you also have community detection. You have different page rank if you're trying to look at maybe some search, some link enhancements. So there's a lot of different capabilities that are being developed. I haven't had an opportunity to play with a lot of them yet, but definitely the similarity ones that I have been working with over the last 3 or 4 months have shown a lot of improvement into my workflow and my pipeline, and making the speed and the process of finding nodes and finding relationships a lot faster and easier. So if you hadn't had an opportunity to look at the Graph Data Science platform, I suggest you do. I think it'll change how you're utilizing graph databases and really turn it into an enterprise type of an application.
Okay, great. And a couple questions about the visualizations that you showed. I think I saw Bloom in there at the end. Can you talk a little bit about how you're leveraging those now, and then if there are any plans to build that out in the future?
Sure, that's a great question there too. Visualization is always something that's interested me, especially within the graph database functionality, because I think it's a way that it shows a lot of information quickly. I was excited to see Bloom come out that interacts well within the Neo4j database. One of the things that I wish I could have shown in that capability is the ability to use parameters within your showcase of a Bloom visualization, where you can create a query with parameters that can then be passed on to your users, and the users don't necessarily have to know Cypher, they just have to know what parameters they have to add to that interface in order to retrieve the results they're looking for. So that's always been great. But there's also many other types of visualizations out there. When I first started utilizing databases over a decade, graph databases about a decade ago, and looking at different visualizations, there's a lot of ways you can do it, both internally with the Neo platform, as well as externally using the Node VS. You're looking at D3, Lincurious, Tom Sawyer. There's a lot of different tools out there that can do that. The thing is to find the one that best fits within your organization and can provide you the opportunities to showcase your results. But what we're looking at doing is hopefully developing, utilizing the Bloom architecture a little bit better and ingesting it inside an application that our end users can utilize a lot quicker and showcase the results for themselves.
Okay, great. Yeah, very cool. Okay, so how did you get buy-in at NASA? What was the process for kind of getting NASA to take advantage of graph databases?
That's a question I get. I can almost guarantee I get that question every time. It almost feels like it, and rightfully so, because trying new technologies, trying new ways of doing things, it's always tough to get buy-in from management. I've tried many different ways. The one that has always seemed to work and I've expanded upon over the years is really trying to find a problem set that is unique, but it's unique in the sense that it's maybe isolated to a small organization, but it can be replicated quite easily across the domain, across your industry or your organization. But it also has a whole lot of high visibility and profile, and if solved, could be add a lot of value to the organization. And I tend to work with those organizations to develop those results, those answers, those visualizations. And then once we get it working for them and show them the value of graph databases in the graph data science algorithms, I then generally do a little one or two page write-up of what we did, how it increased value, how the organization is utilizing it now, or the program or the project, and how they're doing it. And then I generally will send that out to everybody at NASA through our communication means. And inevitably, it'll happen within 30 minutes of sending that email out with the information. I will get 5 to 10 phone calls within 30 minutes asking me, how did you do that? Can you show us how to do that? Can you help us? Can you teach us or train us on how we can do that ourselves? So that starts to get a little bit of an organic buy-in from individuals. And once that happens, management seems to take notice. And as they take notice, they realize the value that's added to it, and they realize they need to do something like this in order to increase their efficiency and to be able to find information a lot faster.
That's awesome. And I have one follow-up question for that, and I think that's all the time that we have. But you've been around the graph database space for so long. What's one piece of advice that you would give to newbies just starting out on their graph journey?
Oh, you're testing my mind here, looking back on the time that I've been doing it. I guess it's part of it. You really have to understand your domain and understand and work with, understand what you're trying to utilize the graph database for. As I was looking at graph database, they just connected with me in how I visualize things and how I think about things. So I guess the one thing I would want to say is to make sure you understand, at least from the onset, the benefits and how you utilize graph databases, because once you start seeing that value, you start getting a little bit more excitement into utilizing graph databases, but then pay close attention to data modeling within a graph database, how you're going to create that, and then make the decision on which way you're going to go, because there are various different ways of utilizing graph database and different types of graph database. Use the graph database that's best for your organization. I find the label property graph databases are best for what we're trying to do in an engineering and a scientific standpoint. So get a good understanding of the inner workings of how that data modeling works, because the better you can model your graph, you can start thinking ahead as to how you're going to build those knowledge graphs and where you're going to assign your properties, or whether you're going to backtrack a little bit here, whether you're going to use your information to create a node or a relationship or a property for one of those two. Is understanding that carefully. I went through a lot of trial and error to make sure when I've created a graph and I've end up having to recreate it because I didn't like how I set up the nodes and the relationships and the properties. So think that through a little bit to make sure you understand, but practice like anything else. Play around with different data sets just so you can understand the concepts, and then you can understand how the development of utilizing not only the Cipher to create queries, but the graph data science platform to analyze and your results, or you analyze your nodes and your relationships already in there to really improve upon how you're going to get that information out and really showcase what the value it can bring to your organization.
All right. Thank you so much for your time, David. It's been a pleasure as always. I'll turn it back to Marilee.
Thank you. Great.
Thank you. Thank you, David. Thank you, Greta. And David, we so appreciate your time and sharing your expertise and your experience with us. It's been a real joy to have you here with us. For those in the audience, I just want to let you know our next session will be starting shortly. So stay tuned and we'll get that underway here in just a few minutes. Again, thank you so much, David.
Thank you, everybody. Appreciate it.